going. So my name is Jim. I'm CEO, co-founder of Hopsworks. So I'm going to talk about Brewer. It's a new AI coding assistant we've been developing at Hopsworks for the last few years. What is Hopsworks? Just before we get started, Hopsworks is a platform for developing and operating AI applications at scale. So you can develop batch AI applications, real-time applications, large language model applications, or agents. And you can run them at scale. And Hopsworks deploys on Kubernetes clusters, so it deploys in the cloud, so managed version in the cloud, but also in air-gapped on-premise environments. And we call it an AI lakehouse because the historical data that we store for training AI models is stored in lakehouse file formats. We also have a real-time layer for serving feature data to real-time applications. We have a vector index for serving RAG examples to agents for large language model applications. And we also have many of the other infrastructural components you need to build an AI system, such as the model registry, there's model serving. And now the latest thing we have is this LLM engineering assistant. So this is an LLM-powered assistant to help you build AI systems. You can think of it as being AI to build AI. That sounds a little bit meta. Okay, so it's a coding assistant. Now, many of you may have heard of coding assistants. Many of you may use coding assistants. You might have heard of Cursor. So Cursor is primarily targeted at developers. It's an IDE, an integrated development environment. And Cloud Code is another example of an IDE that supports instruction-based generation of source code. So little chat window there, you can ask it to generate code. It'll highlight your code and work with it. It's primarily for developers. Then we also have another class of coding assistant, which are web-based. Lovable is a good example from Stockholm, where I'm based. And Lovable enables you to build TypeScript applications, web pages primarily. And you can do it with writing instructions in the prompt. In this case, it's not an IDE. So it's designed for people who are primarily non-programmers. And that's what we're going to look at here. So Brewer is a coding assistant for non-programmers primarily, to help them generate code and generate pipelines as well. In particular, look at that, AI pipelines. And one thing that's kind of interesting is, I'll get into it in a little bit, is that we're going to look at how we go from natural language to what we call a specification. And then from that specification, we'll go to code. And in the olden days, we did this in the waterfall lifecycle model, where the specification would be written down by somebody who has requirements, and then the specification would get thrown out the door, because when we started writing the code, we never updated the specification. But the future I see here is that the specification will be the thing that drives the creation of code, and we'll be able to iteratively update specification, which will generate the code for you. So we won't have that same problem we had before. So I'm going to jump straight in and show you Brewer. This is Brewer just running on the right-hand side, but I'll just go to a demo of it straight away. What you can do is, a good way to get started is to take data from an existing data source and let's just do some analysis of it. So I'm going to do that straight away. We'll just jump in here. So this is Hopsworks cluster running. Brewer is available in private preview at the moment. I think if you have a 4.3 cluster, you might be able to enable it, which was recently released. And you can see it's a button up in the top right-hand corner here. So you open up and you get a chat window. There's a chat history. I've been using it a bit already today. But I'm going to start by just doing an example where I say, okay, where's my data? I've got my data somewhere. I'd like to do some analysis of the data. I'm going to then create feature pipeline to create features from this data that I'll use to train a model, or maybe to, build a vector pipeline for my RAG application. So vector embedding pipeline. But let's get into it. I'll start with my data. So I assume I've got my data somewhere. Now, what I did in advance here was that I did set up a connection to Snowflake. So I'm going to pull in data from Snowflake. So if we look at that, I'm not showing you my password, obviously, but I have some data related to calorie counting. So what I'm going to do is I fill this in advance. So you need the connection URL. LLMs don't help you with passwords and usernames, unfortunately. So you have to fill this in manually. but then I'm just going to mount some tables. So what I'm going to do is I'm not going to copy any data into Hopsworks. I'm just going to mount some tables that I already have in Snowflake. These are quite significant tables. They're quite large. They have tens of millions of rows in them, some of them. But what I'm going to do is basically, I've got 3 tables here. One is users, another one is foods, and another one is a diary or a journal, which is when you're calorie counting, that's what you try and do. You try and maintain a diary of what you've eaten. So we have a bunch of users in here. We have a bunch of food groups that were in here. I'm just filling in the primary key. So when we mount this as a table in Hopsworks, if it's time series data, we'll select the event time column that contains the event time. And if it isn't, then we just select the primary key. So primary key is needed if we're going to use this table in a real-time application, because we might need to look up features for an individual food or a user, or a combination of food and user, which is what we have here in our diary. And there's also a timestamp column here, so I'm not going to indicate that. So I'm just going to create these 3 different tables. I'm really just mounting them. We call them external feature groups in Hopsworks. And it now moved me in there. And those 3 tables are actually down. They should be down at the bottom here. So let's have a look. So these are the 3 tables that were created. We have the users, which looks like this. We have some foods, which are in here. We can get a quick preview of the data that's in here. And this data is in Snowflake. So it's going to go over to Snowflake, pull out a view of the data. We can see we have some data sources, food names, food IDs. And then we have our diary of what the people have eaten. So we have a food ID, a quantity, user, and a timestamp when the user ate that food. So, this could be used to make predictions about calorific intake, people are on diets and so on. And it's quite useful. And you might start by saying, well, if I'm a data scientist, I might jump straight away to a notebook and start running some code. But if I'm not a programmer, what am I going to do? So what we can start by doing is doing some data analysis. So I actually ran a command yesterday. What was it? This one, I think. Let's have a look at it. Draw a chart of the popularity of the food groups. Okay. So I'm going to try that one on the new tables that I've just created. So let's go in here. Say, let's draw a chart of the popularity of the top 10 foods based on the diary and foods feature groups. So I say FG feature groups. Okay, and we run that. So what Brewer is in fact an agent. So it's an agent running in the Hopsworks platform, and it's going to talk to a large language model, and that large language model can be in Hopsworks or it can be an external model. So the agent itself, we can see the agent is in here. This is the agent running at Hopsworks. And what our LLM is telling us, okay, here's a plan. So the plan is the specification. So that's the steps the agent's telling you, I'm going to take these steps. And obviously you as a developer or as a non-programmer can look at this and read them and understand this plan and say, well, is this a good plan? Yes or no? And you might decide to refine the plan by saying, well, I don't want you to take this step or this step. So what it's actually telling us is it's going to do is it's going to read the data in the tables. It's going to look for things like frequency counts. It's going to compute some data around them, statistics, and to get a better idea of what's in there. So what it actually did was it generated a Python program. And this Python program analyzes the structure of these 2 different tables. And if we look down, what it's telling us, it's generating a plan again of what it's going to do in the next steps. And this plan, again, is human readable. You can iterate and improve it and suggest to drop step 4, change step 3. You can tell it what you'd like to do. But it's asking me, does this approach look good to you? I'm just going to say yes, and we can allow Brewer to go ahead with the next step. So it's basically saying it's going to review the features or the columns in the diary group to confirm that food ID and quantity can be used to measure food popularity. Then it's going to review the features in the foods group to confirm that the food ID and name are available, because we'd like to get the name of the food, not just its ID. So we'll have to join some tables here. And then we're going to suggest the aggregated results. So it's going ahead and doing this, and we can even look at the code that it generated for analysis here. So this is pretty straightforward code. It's reading up these 2 tables. These 2 tables are very big, actually. In fact, they're They have tens of millions of rows, I believe. So you can, this takes a little bit of time to get started, so you can leave it run. I can show you also that where the model is running, the LLM model. So in Hopsworks, you can actually deploy. So if you're in an air-gapped environment and you don't have access to, let's say, OpenAI or Claude, you can deploy a model in Hopsworks. This is I have a model registry in Hopsworks, and I've got a Llama 3.1 model in here. You probably would run a better one than that, like DeepSeek or V3 or something like that. But you can have, as large an open source model as you'd like. This one is whatever, 20 gigs large, but you can have bigger ones, of course, if you have GPUs to run it, and you can deploy it in Hopsworks and connect that model up to your code. So this one it's taken a little bit of a while to go. So I'm just going to jump in and show you the one I ran earlier. It comes down to a later stage, and then it's going to generate an aggregation script. So it's actually going through a bunch of steps, and then finally it'll generate the chart for the top 10 foods consumed, and it looks like the following. So this is pretty nice. If I'm a non-developer, I now can do some pretty straightforward EDA, exploratory data analysis on my data before I even get started, just with natural language. Now, let's go in and look a little bit at so I'm just go back to my slides here. Let's go back and look at here we go, get slideshow mode. So let's go back and look at some of the principles behind what we've seen just now. So what's happening here is that we go from natural language, so we have our thoughts and ideas, and we're taking a large language model, and it's going to generate some code. So in this case, it generated Python code, and the Python code then gets executed. So in Hopsworks, we have this agent which runs in the platform. So you have an environment there. It's going to write Python code. It'll even pip install libraries. It'll give you resources. It's connected to the data sources. We saw that we had a Snowflake data source there. So it's able to read from your table in a secure manner. And it's all running securely in the sandbox on a container in the platform. So I showed you generating Python code. And one thing is that everyone's looking at SQL, and we've looked at SQL, of course, as well. The problem with SQL, why we're not generating SQL for these queries, is because LLMs are not great at SQL today. There's a well-known benchmark called BirdBench, where we can see that humans are quite a bit, I think it's at 76% for LLMs at the moment. So there's still quite a gap between human capability in writing SQL and the LLMs writing SQL. So the reasons for that, well, SQL code is quite dense. It's mathematical, based on relational algebra. It's declarative, less predictable than imperative programming languages. But we went ahead and looked at Python code. We're generating Python code because Python itself is a concise, lightweight, imperative, and very popular. So there's a lot of data and a lot of well-documented source code, Python source code on the internet, and in particular on GitHub. You can see it's the #1 language, ranked language at the moment on GitHub. And that means that LLMs, and particularly larger LLMs, have a lot of experience in writing Python code. So in fact, the code I was generated earlier was using Pandas data frames. So you may know other data frameworks like Polars, PySpark, Daft, and so on. There's a bunch of them out there. But so the LLM's obviously been trained heavily on Pandas code. We notice Polars it works relatively well, but needs some hinting, because there's some syntactical choices which are very similar to Pandas, but then LLMs kind of hallucinate. But this can be overcome by writing good system prompts with good, clear examples when a user is going to use a framework that you like Polars, that maybe is not quite as good as they are writing for Pandas. So so we're looking at Pandas code, Polars code at the moment. We know these LLMs are trained on public source code. There's an explosion of data processing frameworks appearing in recent times. Hopsworks also supports frameworks like Flink and Feldera for stream processing. You can run Daft on Hopsworks. If you're developing a framework, you have to get that code out on GitHub immediately. So get your API examples out there so they get indexed, and the large language models can learn how to write code against them as soon as possible. and try and keep your API stable. Obviously, that's a hard challenge for anybody developing a new framework. But if the LLMs are not trained on your code, if the examples aren't out there, you'll need to use prompt templates. So your system prompt, you'll need to have examples, you have to have hints. If you're using a framework that you don't have a static system prompt for, then you'll need to retrieve examples at runtime when the query comes in, and that means using retrieval augmented generation. And that can mean feeding your docs or feeding examples to the LLM so that it knows about the framework you use before you write code. So our particular agent, Brewer, it's connected to RAG. So there's a vector index in Hopsworks, so it's connected in there and it has some knowledge about the latest APIs in Hopsworks. And it's also using function calling. So the way we're actually reading this data from the backend. So from in this case, we can also read from Hopsworks Feature Store, which is a tabular data platform, is that we can read data related to tables. We have users or we have food groups, using the identifier for the user, the identifier for the food group. So we won't go into too much detail on that. Okay, so this is what I looked at already. Is you can take, for example, a table that we call a feature group and say, I'd like to analyze this, and let's see what's in here. So let's have a quick go back and see if we can do something along those lines. You can see we've got a bunch of tables in here. I ran this earlier on. I created some derived feature groups, and I can see there's another one, food popularity, in here. But if we look at this foods one here, let's go in here. So let's just say something like analyze. Oops, something's appearing in here. Analyze the foods FG feature group to Brewer. And let's go back here. It's still running my old query from earlier. Not that one, this one here. It's still running my old query. Okay, it's kind of got stuck for a second there. So we leave it, just keep running on that one. Let's go back. So analyzing your feature group basically involves, again, creating a Python program which will read up your feature group, and you can see here it'll look at particular types of features, so categorical features, numerical features, and it will then analyze them for you. So, for example, if I want to say, please create some features for my new feature group, and then you just define what type of features you want, and I can look at an example in a second, it's going to generate a Python program for you. So let's have a look at an example for that I ran earlier. So we have another one called times new feature group. Okay, so in this case, we can see that, there's a couple of stages it goes through. So we've got a data preparation phase. So I'm asking it to create a new feature called time since previous, and it's calculating it. You can see it's generated some code for it. Let's zoom out a little bit here. I zoomed in too much. Let's just exit that and then give me. Okay, so let me just run that again. Okay, so we're going to go here. Yeah, so the code here you can see is it's logging into Hopsworks. It's getting reference to this diary feature group. It's going to read up all of the data from that feature group. So this is the feature group here. It's saying filter the data after this time threshold. So in fact, I asked it to calculate the data for the last 2 years. So it's generated some quite complex code for the last 2 years rather than having a timestamp object in Python. It computed it numerically. I think actually that's because the column is a numerical column. It's a big int column actually. So it's pretty smart. And then it's going to filter that data for the last 2 years and read it back as a data frame. So it's not calling it a DF, but this is a data frame object. And then what it's doing is it's sorting the values by timestamp, and then it's actually calculating it's filling in. You can see if we have missing values with 0. So now we get a new column with all the 0 values, and then it's going to, this is the analysis phase. Okay. So then at the next step, it's going to do some data preparation. And in this case, it's, I won't go through all of the data in here, but it's looking for missing values. You can see there's quite good description or documentation of the steps it's going through, and we won't go through all of the code here, but it's generating quite a lot of code that it will then run and execute. So this the last step is, okay, that's my analysis complete. Now I want to create the feature group, and it puts it all together into one big program, and it runs the program, and then we'll get a feature group. So this is the feature group that we get, is the times feature group at the end here. So it's this one here. And you can see it wrote some data in here. You can see it has 2,982 rows were written, or 2 million, sorry, there's a K there. And you can get a quick preview over it. Now, one thing I did notice was that there are a bunch of missing values in time since prev. So you want to dig into it and figure out, okay, why are these missing values? It might be because this user, it's the first food item they've eaten, and then the previous timestamp was 0, which would make sense. Then you want to figure out, okay, is this correct or not? Because it may be correct or it may not be correct. So that's what the level of abstraction you need to work with as a developer, rather than working at the Python code level. You can now reason about your data and say, okay, for this user ID, let's take this user ID, this will be correct, this value times since 0, if this is the first piece of food they've eaten. So you can go ahead and then dig into that. And you can go and ask Brewer as well. That would be another way to go about that. Okay. Yeah, so then we saw it creates our feature group, and then off we go. So what's happening here, the Brewer architecture, and this is, I think, an important place to look at the future of programming, in particular for data engineering and feature engineering. What we're seeing here is that I have a chat window, and I ask my LLM to do something, my agent, Brewer agent, to do some analysis, create a chart, create a feature group. And what I get back is the specification. The specification is the list of steps of what I want to do. It's something that I, as a maybe even a non-programming developer of pipelines, will be able to read and understand, and more importantly, refine. I'll be able to refine that and say, no, I don't want you to do it to fill in a value for the time since last feature group. If it's 0, we'll just leave that row out, just omit that row, because it's not going to help me. And then this domain specification, when I agree with it, when we have this forwards and back from the agent to the developer saying, this is what I want to actually create, then it will generate the source code from it. And this is where we looked at LLMs are quite effective at generating Python code from a specification. And the specification should have the Markov property where this specification is all you need to create the source code. So the history of all the chat that we had in our chat window should not be necessary to create the source code that we had there. And then once we have the source code, that's not everything you need, because when we want to create pipelines, we'll need to create jobs, we'll need to schedule them, we need to give them resources. And again, we want to automate that from the original code. And then why we run this inside Hopsworks as an agent, but we're not at the moment, we haven't released an MCP API for Hopsworks yet, although one will come, is that what we're trying to do is enable developers to write these pipelines and run them securely connected to all your data sources. So that you'll now have an environment, a container in which to run this, to test it, to fix errors. You won't need to have the entire, deployment environment available, because it's going to be provisioned for you automatically. I mean, internally, there's a little bit of things happening. We have a web UI. There's a head which talks to a worker. We're going to use an LLM, either in Hopsworks or a hosted LLM behind an API. And then we're able to do things like free text search over chat history as well, because we're storing that in OpenSearch internally. So just a couple more words on what can you build and what becomes an interesting thing to do. Now, this is an example I have from my book I'm going to go through. I'm writing a book for O'Reilly on building AI systems. And the first thing is that LLMs have extensive knowledge. They know a lot about the world. They've been trained on pretty much all data that's publicly accessible on the internet. The challenge, however, is getting them to recall and apply that knowledge efficiently. It's kind of like searching the web in 25 years ago. Some people could do it, but they had to ask other people to do it efficiently. And we're still at that case with LLMs. If you don't need to, if they're not able to get that knowledge, you'll need to add RAG to the mix. So you need to add RAG support if for example, you have a cutoff time on your LLM, that day is not available, and you have changed your API since then. For your framework, well, you need to then add it to make it available to your assistant so that you'll be able to reason about it in the prompt and be able to generate correct code. So prompting isn't a hack, it's knowledge duplication. LLMs are able to generate these working problems. We need guidance to get there, and we need a specification. And if an LLM has learned about a deprecated AI, prompting with the correct context and examples can guide it to use the latest one. And that's something we experience quite a bit. Now, this is from the book. This is one of the things in the book I have is that I'm generating synthetic credit card data. So we're looking for credit card fraud. And the actual prompt is a little bit longer than this, but it gives you an idea of what you need to write. So what we're trying to do is we're saying, okay, I want to create 6 different tables, and they're going to contain information about credit card transactions. And there's going to be examples of fraud in those transactions, because we're going to train a model to identify the fraud and predict the fraud. And we want to use the polars library because it's much more efficient than pandas. We'd like to use the faker library if we need to, because we need to create distributions of feature values, for example. And then we want to, whatever synthetic data we create, we're going to write it and store it in HopsWorks. So this is a typical prompt. You need to have, we talked about this specification earlier. So in the book, what I showed you was this is the specification for creating synthetic data. So you can feed this into Brewer, and it's a lot more complex than the examples we've seen before. But it's describing your tables. It's saying, hey, I want a table called credit card transactions, kind of 2 million rows. These are the columns. This is the description of the column. This is the cardinality. As the distribution of the value for this numerical value or the state time column. So you have to give it quite a lot of detail. So it's not just a case of saying, hey, create credit card transaction fraud data, because in fact, there's no really good examples out there. Banks don't make their credit card transaction data sets open source and public. So LLMs don't know too much about them. You still have to give them quite a lot of prior knowledge. Now, with this prompt, it'll generate the code to generate your synthetic data. And you think, well, that's great, but is this just programming? You're really just programming. And the answer is yes, you're programming, but we're not programming with a programming language now. We're programming with a specification. And, in the olden days, the joke was that what is the specification for your program to make it precise and complete? Well, the specification for your program is the program itself, right? But that's not entirely true, because in this case, we can generate synthetic data without knowledge of how to write and run code in polars, without how to use the faker API. We don't know how to create columns with expected data distributions and cardinality, how to join data frames together composed of different columns, and how to store those into HopsWorks. We don't need to know all this API low-level knowledge, because that's already known by the LLM, and we can work at the higher level of abstraction. Now, the same is true for building AI systems with LLMs. So in HopsWorks, we advocate decomposing AI systems into feature training and inference pipelines. So you don't want to build really big programs when you're prompting. LLMs don't work very well with unwieldy large problems. So if you can generate small, well-defined modules, and you're going to run them, check for hallucinations and problems, compose them into a system, then that's good software engineering practice. So in HopsWorks, we typically will model any AI system as a set of pipelines. You can call them machine learning or AI pipelines. So feature pipelines that take our data, as we have from Snowflake, and save it into feature groups. Training pipelines, which will take the feature data and train models, and they'll do it via what we call feature views. And then inference pipelines, which will take trained models and new inference data and make predictions. So you're really writing these 3 programs, the feature pipeline, training pipeline, and inference pipeline, and that would become smaller, more manageable programs that your LLM can handle, by trying to build a bigger monolithic problem won't. And of course, you've got logging as well because you want to, when you're making predictions, you want to store the logs in order to improve the performance of your predictions over time. So like, just to give you a little bit on the internals, if we just take the feature pipeline, because we kind of had a look at that briefly, it actually breaks down an agentic workflow into a series of steps. So if you think of this as a line graph program, we have a set of nodes. It's a workflow. We have a user input in, and then there's some data source. We do data analysis. So that's our first step in the LangChain graph. We have a data preparation stage, and then we have a feature group creation stage. And like I mentioned before, in order to be able to iteratively improve these steps. So for example, if you miss something in data analysis, you can say, hey, go back and do this step. And this is where specification helps us with. And then for data preparation, again, if it's missing something, you tell it to go back and complete that step before it keeps going to the next step. So that's it. I mean, that's a relatively brief intro to Brewer and where we are today. Brewer will be released in Q3. So if you want to try that today in private preview, please reach out to us and we can get you started. If you want to learn more about building AI systems, I recommend you download the first 7 chapters, in fact, of this book that I'm finished writing actually now on building machine learning systems with a feature store. It'll be released at the end of Q3 fully, but you can get early release. And if you want to learn more about building large-scale AI systems, and in particular how we manage data in them, then I strongly encourage you to attend the Feature Store Summit on October the 14th. If you're interested in submitting a talk there, the call for proposals is still open for another 2 weeks. So you still have time to submit a proposal. And with that, I'd like to thank you and wish you luck on your journey in building AI systems with large language models.